Okay, so our next unit is actually a continuation from Unit 5. So this is Unit 5, Part 2, is the start of your notes. So I'm going to title it up at the top for you so that when you're studying, you know exactly where to look. So this is going to be Unit 5, Part 2. So it's its own separate test, but it does obviously require some past knowledge of things. So we're going to be graphing more functions, more rational functions specifically. So if we look at what rational means, we are talking about fractions. So if we have a fractional equation, okay? So in our last Unit 5, we did not do fractional ones, but a lot of the stuff that we did there will apply here. So here's an example, f of x over g of x. So you have your fraction where they're polynomials. And there's going to be a bunch of different things that you're going to have to do to be able to graph them. That's our goal. So I'm going to go through all of these separately. And in the next section, you're going to put it all together and actually do the graphing completely. Okay, so there are multiple steps to it, and we'll be practicing each one. And then the next section, we'll be doing all of it together. So to find the domain of the function, since it's a fraction, we know that the denominator cannot equal 0. So that's something that we have already learned. So when it asks for the domain, all you have to do is set the denominator not equal to 0 and solve. That is not new. Parent functions, 1 over x. We have already graphed 1 over x. So those are the points 1 comma 1, 2 comma half, negative 1 half, negative 2, and then it is reflected among the origin. So it looks like this. So you can graph those 6 points. Now, something else that you should graph when you see y equals 1 over x is remember there were asymptotes. So we had talked about this. Asymptotes mean that it gets closer and closer, but it's not going to cross it. So here are the asymptotes, and you have to mark them. They have to be there. If you do not have the dashed lines, it will be wrong. So that's y equals 1 over x. If we graph y equals 1 over x squared, that's the other function you need to know. Notice that the exponent is even. When that happens, and you can make a table if you want, but you're going to get, when x is 1, for instance, you get 1 over 1 squared, which is 1. When you plug in 2, 1 over 2 squared is a fourth, so this is graphed at a fourth, so obviously this gets hard to graph. So just kind of do your best with graphing these points here. And again, it's going to get closer and closer and closer to its asymptote, which we'll draw in a second. Now notice how they're on the positive side, because remember when you do x squared, even if you plug in a negative number, it makes it positive, okay? And your asymptotes are still on the x-axis and also on the y-axis. So again, the actual graph will not cross that. Now we're going to talk about finding vertical asymptotes and horizontal asymptotes. So vertical asymptotes are vertical. They go up and down, vertical. Horizontal ones are the ones that go left to right. They're horizontal, okay? So this is a vertical asymptote and this is a horizontal asymptote. You're going to be drawing, again, these dashed lines in your graphs, and those are asymptotes. So we're going to find out some more information about them. So let's take a look at that. So a vertical asymptote, first of all, it needs to be in lowest terms, and they're going to be the real zeros at the denominator. So to find them, set g of x equal to 0. So what that's saying is, because you're looking in the denominator and g of x is what they call the denominator, you're going to set the denominator equal to 0 and solve. And that will be your vertical asymptotes. When we say lowest terms, we just want to make sure that you factor. Okay, so if it's not factored, go ahead and factor the numerator and denominator. And then you want to simplify. Okay. Something else that's going to be important is the multiplicity. Remember, the multiplicity is your exponent on each factor, right? So we already know what the word multiplicity means, but if you forgot, it means the exponent on each factor. And when we talked about the other ones, we talked about if it's an even exponent, it's going to bounce, and if it's odd, it crosses. Well, these multiplicities are also going to talk about what direction the graph goes when it gets close to an asymptote. So it's either going to have an odd multiplicity or it's going to have an even multiplicity. And this is when we're talking about the denominator here, okay? So when you're looking at the denominator and you're looking at the multiplicity, you can have an odd or even on each factor. If it's an odd multiplicity, kind of like y equals 1 over x, notice the exponent on the bottom was odd. It's going to look like, and I'm going to zoom in, just like the graph we had above. And we've got the asymptotes here. And what happens is they are going to go at this spot here, at this asymptote. When it's odd, it's going to go in opposite directions, okay? So that orange part there, notice that the arrows go opposite direction. Again, that's because the multiplicity is 1 at that 0, right? Because the exponent of 1 over x, that x has an exponent of 1. Very similar when you see y equals negative 1 over x, except the leading coefficient is negative, so that means that your graph would reflect. So now our graph just has to go ahead and reflect. So it would look like this. You still would have the same asymptotes, right? And again, the arrows would go in opposite direction at the asymptote, right? One's going down, one's going up here at the asymptote. That's what that means. And again, because of the negative sign, it's flipped. Okay, and again, the arrow's going opposite direction because the multiplicity on that 0 is 1. It's odd. Well, what happens when it's even, like 1 over x squared? Or whatever the 0 is. So we already looked at 1 over x squared, so we already know that it looks like this. And this time at that asymptote, notice that they are both going in the same direction. So notice that the arrows at the asymptote, at the vertical asymptote, they're both going up. They're both going in the same directions. So arrows go in same direction. And again, that's for the graph y equals 1 over x. And again, the square, because it's even, they're going to go in the same direction. Now, it's the same thing if it's y equals negative 1 over x. And again, because it's even squared, we're going to have an even exponent there. So when we graph it, first it's reflected because of the negative sign out in the front. So they're not going to be going up. They're now going to be going down. So they look like this. You still have your asymptotes, but because it's an even exponent, notice that at this vertical asymptote, the arrows are going down. They're going towards each other. That's the important thing. Okay, so we're going to learn one more thing, and then we're going to start to put it all together. Okay, so the last thing we're going to talk about is a horizontal or oblique. So again, vertical, which we just talked about in step 4, is up and down, and vertical is going to be, or horizontal is going to be left to right. And then we're going to talk about zeros. So I'm going to put a reminder for myself so that I do not forget. Number 6, we have to talk about zeros as well, or not zeros, holes. Holes, holes, holes. So add that to the list. Okay, so you could have either a horizontal asymptote or an oblique asymptote. So we're going to talk about those two things. a horizontal asymptote, just like it sounds, horizontal, dashed. Oblique asymptote is going to be something like a linear equation. Sometimes you're going to see it be U-shaped, but it's not going to be horizontal or vertical, okay? So there's 3 different cases for that. So the first case is if the numerator is greater than the degree of the denominator. So if the degree of the numerator is greater than the degree of the denominator. And again, we're talking about degree. So the degree is your highest exponent if it's in standard form. When that happens, we're going to be finding using synthetic division. So that's why synthetic division is important again. And again, you are going to end up with an oblique asymptote, or maybe a U-shaped one. The next case is if the degree of the numerator is equal to the degree of the denominator. So that's our next case. So if the numerator's degree is equal to the denominator's degree, it's very easy. This one automatically will have a horizontal asymptote, and it's going to be y equals the leading term numerator divided by the leading term denominator. So there's really not work to show for it. You just take the leading term, if it's 2, and the leading term on the bottom is 3, then it would be 2 over 3. And then if we take a look at the last case, so the last case would be if the degree of the numerator is less than the degree of the denominator. So the degree of the numerator is less than the degree of the denominator. It would look like this, and it would have the asymptote y equals 0. And it would just, you know it or you don't. So I hope you are writing all of this down, because this is a lot of facts that you have to know. And if you don't write this down, you are not going to remember these facts. It's a lot you actually kind of have to practice it a lot and memorize it. This is a lot of facts, so you should be taking great notes. The last thing we're going to take a look at is number 6, which is holes. And holes, they're literally going to be little circles on the graph, okay? And they'll look something like this. You'll have a graph and there's literally a hole you draw. And once they're in lowest terms, factors that cancel form holes. So we'll talk about that as well. So now let's actually get to some practice. Again, we're doing each one separately, but in the next section, what you're going to be doing is you're going to have to find all 6 of these parts in one question. Right now, they're just asking you information separately, okay? So when it says find the domain, if you don't know what to do, okay, domain, go back to step 1. Oh, step 1 says domain, use the fact the denominator does not equal 0. Okay. So I'm going to go to this and I'm going to set the denominator not equal to 0. That's what that means, okay? So again, to the domain, denominator cannot equal 0. And again, the denominator can't equal 0 because then you get an undefined number. It doesn't work. So square roots and fractions were the 2 things I said you have to look out for domains. So all of these will have fractions, okay? So we're going to go ahead and set the denominator not equal to 0. So we've got x plus 5 does not equal 0, and you're going to solve that. That means x does not equal negative 5. X can be any other number, but it cannot equal negative 5. If you put that as an interval, that means negative infinity until negative 5, union negative 5 until infinity, all in parentheses. So it depends how the answer asks, but you could put it like that. Next one, same idea. So I'd like you to actually go ahead and stop, and I'm going to have you solve this one, please. All right, welcome back. So if you were following along from above, all you do is you set the denominator not equal to 0 and solve. So here, x squared minus 4 does not equal 0. I'm going to go ahead and add 4 to both sides. And then I'm going to go ahead and square root. So x does not equal plus minus 2. So you should get both of them. Or you could have factored that into x minus 2 times x plus 2 and does not equal 0. And then you set each factor. So x could not equal 2 and x could not equal negative 2. So either method that you used would work. So your answer, if you put it as an interval, would be negative infinity until negative 2, union negative 2 until 2, union 2 until infinity. So either of those, they mean the same thing, would be fine. It just depends what notation they want you to use. All right, example 2 is sketching. So if we take a look at the sketching problems, we're going to be looking at their movement up, down, left, and right, and their core graph. So the core graph for this one is y equals 1 over x. And because of the movement, the minus 2 means you're going to go down 2. And because of the plus 1, you're going to go ahead and go right 1 because it's inside the function. So that's your left and right. So we're just using transformations that you did a lot of first semester. So I'm going to take my asymptotes, which remember we're on the x and y axis. So if you think about your core graph really quick, that was the one that looked like this. You can go back and look at your notes if you need to. I have to move one asymptote down 2. And I have to move the other one right 1. So first thing I would always do with these is move my asymptotes over. There's no multiplying in this one, right? So you don't have to worry about that one. So I can just go ahead and take my core graph, which started at the points, and move them. But I always kind of remember that this one, if there's no multiplication, is 1 spot away and 1 spot away. And then when I go to 2, it's a half, and then it's a half, and a half, and a half. Looks like that. And those 6 points is enough to graph it. And we're done. I'm going to go ahead and do B with you. The only difference really in B is notice that the core graph is not 1 over x. The core graph for part B is 1 over x squared. So if you go back and look at your notes, that one looks like this. So that's your core. Your movements, you should know this is going to go up 1. And because this is minus 2 on the inside of the function, it's going to be right 2. So I'm going to take those asymptotes. They're the same asymptotes as before. I'm going to go ahead and move one of them, the vertical one, right 2. And I'm going to move the other one up 1. And then my points are pretty similar, except instead of a half, 1 over 2 squared is a fourth. So this one's actually a little bit closer. Same here, it's just a little bit closer. And that's it. Again, they're just asking questions piece by piece. So the next one says, find the vertical asymptotes for the function below. We're missing directions in all of this page. We also want you to find the holes. So add this in, find the holes and vertical asymptotes. So I'm going to write that under every single set of directions. Find the holes and, same thing here, find the holes and. Okay, so we're going to be finding holes under every single one if they have them. So what we're going to have to do for this one is we have to go ahead and put it in lowest terms and set denominator equal to 0 and solve. Okay. All right. And if you want to go back and look at holes, holes are factors that cancel. So if we go back and we think about that, holes are factors that cancel. Vertical asymptotes. Once you factor it, and in lowest terms, you're going to set the denominator equal to 0 and solve. Okay. So let's take a look at this problem here. We're going to go ahead and start by factoring it, okay? So when I factor this problem, the numerator x squared minus 9 is x minus 3 times x plus 3 divided by the denominator, two numbers that multiply to 6 and add to -5 are -3 and -2. So I'm factoring. Notice something very interesting happens. Notice these x minus 3's are the same. That is what we call a whole when you have the same factor. So that is what we call a whole. So the first thing I'm going to go ahead and write down is my whole. Again, it's wherever they cancel. When you have a whole, you're going to go ahead and solve for the actual point. So your answer for a whole is a point. So I'm going to solve. The factor that canceled was x minus 3. I'm going to add 3 to both sides. I get positive 3. That's just the x. Now I have to go ahead and plug it back in. So I'm going to plug f of 3 back in into the simplified form, the lowest terms. So I'm going to plug it into 3 plus 3 over 3 minus 2. So I plugged it into this part here, okay? And when I solve for that, I get a number of 6. I get 6 over 1, which is 6. So that means my point for the whole is 3 comma 6. So when we get to graphing it, which we will in the next section, you would have a hole there. You'd literally draw a circle. Now let's go ahead and take a look at the vertical asymptote. That's the second part that it asked us about. So the vertical asymptote says once in lowest terms. So again, this is your lowest terms here. You're going to set the denominator equal to 0 and solve. Well, that means we're going to set the x minus 2 equal to 0 and solve. And when I solve that, I add 2 and I get x equals 2. That is your vertical asymptote. That's your answer. All right, let's go ahead and take a look at part B here. So for part B, same idea. We're going to start by factoring. I'm going to factor the denominator. 4x squared minus 9 is a difference of squares. So I can write that as 2x minus 3 times 2x plus 3. And that is my factored form. Nothing cancels. So the first thing you can go ahead and answer is the wholes. Nothing cancels here. Okay. So under wholes, I would write none. Perfect. Done with that part there. All right, let's go ahead and now look at the vertical asymptotes. So for the vertical asymptotes, it's in lowest terms. You're going to set the denominator not equal to 0 and solve. Actually equal to 0. I'm so used to putting not equal. I meant equal to 0. Not equal is for the domain. So 2x minus 3 times 2x plus 3 is equal to 0. So I set each factor equal to 0. That one's going to get me x equals 3 halves. And this one, when I set it equal to 0, I subtract 3 and divide by 2. X equals negative 3 halves. Again, you can do that pretty quickly. If you need to show all the steps, go ahead. But I think that's something that you can kind of do to save some time. So that is your answer here. Those are your vertical asymptotes. Notice vertical is bucks. It's always going to be x equals bucks. X equals is going to be your answer. Always, always, always. If you don't have that part, it is wrong. Bucks. It's a vertical dashed line. All right, let's take a look at example 4 and 5 are the same directions. Find the wholes and the horizontal or oblique asymptotes for the functions below. First thing we're going to go ahead and do, and we already talked about what wholes are, for the asymptotes here, for the horizontal or oblique, this is when you look at the degree. So you're going to look at the degree of the numerator and denominator. And remember, you have 3 different cases, okay? And we're going to go through all 3 of the cases. There's 4 examples, and we will hit all of the cases, okay? And if you're wondering what I'm talking about, if you go back, this is step 5, where we're talking about horizontal and oblique asymptotes. Again, I said I hope you take good notes there, because that has all the information of what you're supposed to do. So the first thing you're going to try to do is factor, just to see if there's any wholes. 2 numbers that multiply to 18 and add to -5, there is not. You can try to factor the bottom as well. There are no numbers that multiply to -2 and add to 5, so I'm going to keep it like it is. So there are no wholes. So let's start with that. Okay, the next thing we're going to go ahead and do is find the horizontal or oblique asymptote. And what you have to do is look at the degree. So when you're looking at the degree of this problem, very important, notice the degree of this one is 2 and the degree is 2. So we have degree 2 equals degree 2. So the numerator is equal to the denominator's degree. When that happens, you take the leading coefficients. That's what it says back in the directions, if you go back and read it. So that's 3 over 2. So your answer is y equals 3 over 2. Horizontal, hoi, y equals. That's why that one is y equals, okay? Done. That's all you have to do for that one. You have no work. You either know it or you don't. Let's take a look at part B. Again, we're going to go ahead and try to factor it. Two numbers that multiply to -4 and add to -1. You would have to go ahead and split the middle. So I'm going to save some time for us. I've already factored it, but you would have to split the middle for that one. And when you factor it, it would become x plus 1 times 3x minus 4. If I were you, I would just do the work on the side. Divided by the x plus 1 is factored. So something interesting happens here. So my wholes I did in purple. Notice the x plus 1's cancel. So the first thing we're going to take a look at is wholes. They factored at x plus 1 cancel. So I'm going to set it equal to 0. That gives me x equals -1. And then remember, you have to go and plug it in to find the y value. So I'm going to plug it back in into the lowest term. So 3 times -1 minus 4. I guess I don't really need those parentheses there. And that's going to get me -7. So my point for my whole is -1, -7. So when we get to drawing, we'll actually draw a hole there. Now let's go ahead and take a look at the degree. This one has, now when you look at the lowest terms, the numerator has a degree of 1. So the numerator, or the numerator degree is 1. The denominator degree is equal to 0. So the numerator is greater than the denominator. This is the one where you have to use synthetic division. But the problem with this one, you can't use synthetic division because there's nothing in the denominator left. Right? We canceled it. So you can't actually do anything if there's no number to divide by. So there is none. And that's your answer. All right, continuing on with the exact same directions. For example 5, we're going to start by factoring if possible. So for the top one, two numbers that multiply to 6 and add to -1, can't do. The bottom one is an x cubed one, so we don't have to worry about doing anything. Cannot factor that. So we're going to look at the degrees here. So the degree of this is 2 and the degree of this one is 3. So the degree 2, and that is from the numerator, and the denominator's degree is 3. So this means the numerator is less than the denominator, right? So when that happens, automatically, and again, that's why I hope you wrote this down. If you go back, when the numerator is less than the denominator, it's automatically y equals 0. Again, you just have to know that. That is the asymptote. So it's going to have a horizontal asymptote at y equals 0, and that's your answer. Now the wholes, I forgot to do the wholes, but the wholes, because it couldn't factored, so things are not canceling, there's no wholes, right? We couldn't factor, so there's no factors that cancel, so the answer is none. Usually I look for wholes first, but it doesn't change the answer. All right, one more to go. Again, we're going to go ahead and try to factor the top. It's an x cubed, can't do. And the bottom is x minus 2, can't factor, so it's already factored. So the first thing we know for wholes is there's none. So we're done with that. There's nothing that cancels, we can't factor. So now we're going to go take a look at our asymptotes, because again, I said it's the same directions. So we're going to go ahead and look. The numerator's degree is larger than the denominator. So usually I kind of just go ahead and write numerator greater than denominator because I look at those numbers. So when that happens, it says we use synthetic division. So this is how you're going to use synthetic division. You're going to take the top part and divide it by the bottom. So you're dividing, since it says x minus 2 on the bottom, you're dividing by 2. You're going to use your leading coefficients on the top, which is 2, -1, 0, 3, because we're missing the x term. So you have to synthetically divide now. So you're going to go ahead and bring down the 2. 2 times 2 is 4. Add down. That's 3. 3 times 2 is 6. Add down. That's 6. 6 times 2 is 12. Add down. You get 15. That's your remainder. Your remainder does not need to be 0. If it was 0, that means it would be a factor and it would be a whole. So you should not be getting 0. So the leftover part here is going to be what your asymptote is. So your asymptote for this one, and again, if we had x cubed and we're dividing by x, it goes down by 1. This becomes an x squared and an x, and that's your constant. So this is actually going to be a quadratic asymptote. So this is going to be y equals 2x squared plus 3x plus 6. You can ignore the remainder, and that is going to be your quadratic asymptote. And that is it. So again, these are just individually asking you questions. We're going to end up doing all of these together in one problem in the next section. All right, I will see you in class.